So today we will discuss about the topic fermentation. We'll start with the new topic fermentation, where you will be studying about the various types of fermentations like lactic acid, alcohol, propionic acid, butyric acid, butanediol, mixed acid. Okay. These fermentations are helpful when you talk about the principles of industrial products and also sometimes regarding spoilage and at times for classification of microbes. Keeping this in mind, we will learn this. First, I will take up lactic acid fermentation. We'll go with the lactic acid fermentation topic, where we will be following it up as homolactic acid and heterolactic acid. You already studied this. It's like, already you've studied it, but I will write the flowchart, complete flowchart for today. Let us start with glucose. Okay. So let me write the heading as lactic acid fermentation. Already I given you the split syllabus, so you know what are the topics in fermentation. Let me not go and sign on that. Let me just go directly with the first one, lactic acid fermentation. It is brought by which is the microorganism involved here. Lactobacillus. Okay, lactobacillus can be one of the examples of lactic acid fermentation. Bifidobacterium. These are the examples. Lactobacillus, acidophilus, Lactobacillus vulgaricus, like that. Okay. So, can you tell me where we come across this as an important organism in our daily products which we consume? I'm asking about
so curd fermentation of curd.
Curd formation is nothing but lactic acid fermentation. Okay, idli batter also comes under this fermentation. So we are classifying lactic acid fermentation into two types. One is called as homolactic acid fermentation. Another one is called as heterolactic acid fermentation. Very important for the examination. All of you have to learn this properly. Okay, please learn these fermentations properly. Homolactic acid fermentation and heterolactic acid fermentation. Many question papers you have seen, old question papers. This question is asked. Very common question. Okay. Homolactic acid fermentation ends in giving two molecules of lactic acid. Okay, it gives only lactic acid here. Whereas heterolactic acid fermentation gives one molecule of lactic acid, okay, and one molecule of alcohol. All of you following this? Did you understand? Homolactic acid gives two molecules of lactic acid in the end, whereas heterolactic acid fermentation gives one molecule of lactic acid and one molecule of alcohol. Can you tell me what is this fermentation which you already studied this? Anyone can tell me? This already I told you beforehand. I told you that will be this is the same like heterolactic acid. Somewhere we learned this, where you get lactic acid and alcohol.
Phosphoketones.
Pardon me? Somebody told that.
Phosphoketones. Ketolase.
Ketolase. Yes, exactly. So this is exactly the PK pathway. Phosphoketolase pathway. This is a PK pathway. Okay. So PK pathway is what we come across here. Homolactic acid will give only lactic acid. Heterolactic acid will give both acid and alcohol. Lactic acid and alcohol. So PK pathway, phosphoketolase pathway. Now we have to look into the flow chart now. This is a basic classification which we have to understand. Students, can I go ahead? You understood this basic difference now? Yes? Are you taking down? Yes or no? Are you noting?
Yes, sir. Yes, sir.
Okay. I'll send you whatever notes I have, students, because I used to make them write in the class now. That I will forward it to you. But basically understand in the class what we are writing, what we are doing. Okay. Now I will take up lactic acid fermentation first. I will take up lactic acid fermentation topic. You want me to teach heterolactic acid PK pathway? Already you know now, isn't it? I will not be wasting time on heterolactic acid because already PK pathway is known. All of you should write that. What you do, practice at home and write heterolactic acid fermentation completely once again. I will see your books when you come. All the pathways, girls, don't keep it in the form of soft copy. You have to write it. Talking about lactic acid. This is again a revision for you. You will not do it, so I am writing it on the board once. Remember, lactose will convert into glucose and galactose. Okay, galactose also converts to glucose. Here the enzyme is beta galactosidase. All of you write down this. Beta galactosidase. Okay, that will help in converting this. And here it is galactokinase. Okay, anyway, we get glucose. That's the meaning of the topic, beginning of the topic. Now, what should we write now? Glucose. I write it fast. You also know about this pathway. I will not wait much for this. You have to be knowing this already. I'm talking about EMP pathway. Okay, I'm talking about EMP pathway. Glucose converts to glucose 6-phosphate. Then it converts to, anyone can tell me, fructose 6-phosphate. Then fructose 1,6-diphosphate. You should write fully. If there's a 10 marks question only on lactic acid, you must write full names and write. Okay. Since already you learned it, I'm writing in the short form. Otherwise, you must write phosphate, full names. Okay. You can take down, or if you're already having this, you write along with me, at least you get some idea. Fructose 1,6-diphosphate will split into glyceraldehyde, 3-phosphate and dihydroxy acetone phosphate. Glyceraldehyde 3-phosphate converts into, I write this side. There is the top portion. Glyceraldehyde 3-phosphate converts into 1,3-diphospho-glyceric acid. Exactly the first pathway what you have learned. EMP pathway you should follow. Then it converts to 3-phosphoglyceric acid. Then it converts to 2-phosphoglyceric acid. Then further to phosphoenol pyruvate. Then converts to pyruvate or pyruvic acid. All of these are how many carbon? How many? All of you understood this one? First pathway what you studied, EMP pathway, starting studied now, that one. You can hear me now? Shavya?
Yes, sir. Yes, sir.
Okay, this is exactly same pathway. Okay, just to revise back, Glucose uses 1 ATP here to form glucose 6-phosphate. Fructose 6-phosphate uses 1 ATP here. I'm writing only important things. Then this side you have addition of inorganic phosphate, conversion of NAD to NADH2. I'm sorry, not there. I'm sorry. This is here. Below this, I should write it here. All of you see down here. This one you take phosphate here. Inorganic phosphate is added. NAD converts to NADH2. What is this called?
Oxidation.
Yeah, reaction is oxidation, but NADH2 is reduced. No, is reduced. Okay. I know it's a reaction is called oxidation. Yes, I understand. Then coming back here. 1,3-diphosphogylic acid becomes 3-phosphoglyceric acid. See your EMP pathway. All of you take your book and see EMP pathway once. Are you keeping the book with you? What is formed here? What is formed here?
ATP.
ATP. This is isomerization. Two phosphoglyceric acid to phosphaenol pyruvate. What is it? Removal of water. Phosphaenol pyruvate to pyruvate, what is formed? Again, ATP is formed. Any doubts in this, students? All of you followed this? This is same like EMP, exactly
Yes, sir.
same like EMP. When you were in regular classes, I would have told you to write this and come. Since you're at home, I'm writing it on the board just to revise, that's all. Okay. All of you have to write the EMP pathway once. Till which one? Till pyruvic acid. Same thing you should write. Now, can you tell me the name of the enzymes? Name of the enzymes you tell me, let's see. Glucose to glucose 6-phosphate. Name of the enzyme.
Exokinase.
Okay, good. Go on. Exokinase. Glucose to fructose 6, glucose to fructose 6-phosphate. Yeah. This is phosphorylation, first one. You want me to write all this or it's okay? You know everything. I can go for last step that time. All of you familiar with this now? What, students? Glucose 6-phosphate to fructose 6-phosphate is isomerization. Fructose 6-phosphate to fructose 1,6-diphosphate is again what? Phosphorylation. These are all 6-carbon compounds now. This becomes 3-carbon compounds. What is the name? What is the step called as?
Cleavage.
Aldolase. See, exactly same. Everything EMP pathway should write first. Last step only will change. That's all. Enzyme here. Phosphoglycerol
Kinase.
kinase. Then phosphoglycerol
Mutase.
Then what is this enzyme? Enolase. Then what is this enzyme? Did you all understand? Pyruvate kinase. Which is substrate like phosphorylation in these?
So 1,3 diphosphoglyceric acid to 3 phosphoglyceric acid.
Yes. And last step.
And the last one.
Substrate level phosphorylation. Now, what is our topic? Our topic is lactic acid fermentation. What you should do now, write everything like this, and then only you should write like this. What you should write? Pyruvic acid becomes what? What is this? What is that? Pyruvic acid converts to what? What is this, students?
Lactic acid.
Yes. Lactic acid. How you know? It uses
Reduction.
Reduction.
It converts NADH2 to NAD. Hydrogen is added to pyruvic acid to become lactic acid. This reaction is called as reduction. This is called reduction. This is called reduction. Name of the enzyme is called lactate dehydrogenase. Lactate dehydrogenase. Got it? No, everybody understood. What I've taught you is homolactic acid fermentation now.
Yes, sir.
How many lactic acid should form according to homolactic acid fermentation? How many
One.
should form? How many
One,
lactic
sir.
acid should form?
2, sir.
Okay, 2 lactic acid should form. Why? Because we'll get 2 pyruvates. How do we get 2 pyruvates? Anyone can tell me? How do we get 2 pyruvates? Take your EMP pathway.
One glucose molecule.
Everybody. Check the EMP pathway. Tell me, how do you get 2 pyruvates?
Again converted to
So
glyceride
DHA becomes
Correct. See here, all of you see here. DHAP converts to G3P. DHAP converts to G3P. Undergoes same reaction. So everywhere what you should write? What is this? What is this? 2 NAD, 2 NADH2. Two molecules. 2 NAD becomes 2 NADH2. Similarly, everywhere, same thing you should write. What you should write? 2 molecules of 1,3-diphosphoglyceric acid. 2 molecules of 3-phosphoglyceric acid. 2 molecules of 2-phosphoglyceric acid. 2 molecules of phosphates. Everywhere you should write 2 ADP, 2 ATP, 2 water, 2 ADP, 2 ATP. 2 NADH2 becomes 2 NAD. Are you clear? All of you understood what I'm saying? Do you understand
sir.
this?
so
Yes. Tell me. Everywhere you should write 2. 2 molecules of lactic acid. Shall I send the pic?
Yes, sir.
1 second. I'll write the enzyme for this also. Phosphoglucose. What is this? Glucose 6-phosphate, fructose 6-phosphate. Phosphoglucose.
Isomerase.
Phospho. Fructose. What? What? Kinase. Aldolase. Everything is same, children. Whatever you studied earlier, everything is same. Only last step you have to write pyruvic acid becomes lactic acid. That's all. One question to you. If this question is asked for 5 marks, what will you do? Or 2 marks, what will you do? If question is asked for 2 marks, what you do? See the board. See that side, right? See here. Glucose. 6 carbon. Write down this along with me. Pyruvic acid, 2 molecules, 3 carbon. Okay. Then here what we should write? 2 NAD gives 2 NADH2. Can you tell me how many ATP is formed totally in glycolysis? By substrate level phosphorylation, how many ATP is formed?
14.
14.
No. In EMP pathway,
10. 10.
10 is without NADH2 I'm asking. Without NADH2 I'm asking. Substrate level phosphorylation I'm asking.
4.
4, good.
4.
4. 4 ADP. Write down all of it, write down what is confused. 4 ADP becomes 4 ATP. Okay. Now understand. Pyruvic acid uses NADH2. See here. This is easy to understand. Whatever I wrote there for starting is easy to understand. See here. Pyruvic acid uses 2 NADH2. See here. 2 molecules of NADH2 and it becomes 2 NAD. Means this NADH2 is used. NADH2 will not give ATP. Lactobacillus depends only on substrate level phosphorylation for ATP. NADH2 is used in the reaction. What reaction is this called? I told you this some time back. Whenever hydrogen is added, what do we call this reaction as?
Reduction.
Reduction. Good. So what do we get here? 2 molecules of lactic acid we got. What's the name of this enzyme?
Lactase dehydrogenase.
Lactate dehydrogenase. Did you all understand the summary? Glucose is pyruvic acid. NADH is developed here, produced here. It's used up in the reaction for reduction to form lactic acid. All are clear in this? Yes.
Yes, sir.
Yes, sir.
Doubts, mark. Any doubts in this? For 2 marks questions, you can answer like this. There's no meaning in writing full glycolysis. Only when it is 10 marks, you should write fully glycolysis. Otherwise, you can write like this. If you say yes, I can continue. Anybody did not understand this? All have understood that means. Yes?
Yes, sir.
Okay. Now students understand, I'm talking about net gain of ATP. I'm talking about what? Net gain of ATP for homolactic acid fermentation. Right. Both NADH2 is used for reduction. Both NADH2 is used for reduction. Good. So follow this. 4 ATP is formed by dash. What is it called? Anyone can guess?
Phosphorylation.
Huh?
Substrate level phosphorus.
Yes, good. Substrate level phosphorylation. 2 ATP is used. Children, you can write only like this. No need to write table now. For fermentation topics, don't need to write the table like over it or for EMP, HMP, ED and all, not required. You can write in points. I'll send you notes for this. 2 ATP is used in glycolysis. 2 ATP is used in glycolysis. Net gain is equal to how much? 4 ATP minus 2 ATP is equal to how much? Did you follow this? See slowly, understand slowly, go through slowly. Any doubt on that, you tell me. I'll take a photo meanwhile, you can go through. I'll send it in the WhatsApp. I'll send the notes also, just for your reference, I'm sending you this. Okay, I think I've sent it. Could you follow?
Yes, sir.
I'm sending the WhatsApp once again. So this is little different for you. So I have made you understand this. What is lactic acid fermentation? So let us not go for heterolactic acid fermentation. You write it as an assignment. Completely should write. All of you should write. Will you do it?
Yes, sir.
Okay. PK pathway is done. Write in all of you write in the book now. Heterolactic acid fermentation. Refer on the PK pathway. You have to write the PK pathway for that. Can you tell me how many ATP is generated in PK pathway? How many ATP is generated? Net gain of ATP is how much?
1.
1 ATP. I've already explained that to you. Here, please understand in this whatever homolactic acid, 4 ATP is formed, 2 are used in glycolysis, glucose 6-phosphate formation and fructose 1,6-phosphate formation. Therefore, net gain is only 2 in homolactic acid. 2 molecules of lactic acid is formed, 2 molecules of ATP is formed. NADH is formed is used up in reduction reaction. Therefore, NADH will not donate ATP separately. Okay, now clear? All of you are clear about this? Any doubts in this? Lactic acid fermentation will be done by this. One point you should write significance. What will you write for lactic acid? What will you write for lactic acid? Significance. Importance. What will you write? Significance. What will you write, children?
So used in curd and
Basic principle.
it.
Yeah, good. Basic principle in preparation of curds, yogurt, and all fermented milks and all fermented milks. We need lactobacillus for these things. Okay, that's a basic thing. Other than this, it is going to be having importance in probiotics. Probiotics mean during fermentation, some compounds are produced which is useful in developing immunity. Okay, you can develop immunity by taking curds. You can have, it is a very good thing for even anti-aging, antioxidant, all those properties are there. Antibacterial compounds are there. That is called as antibiotics. Whenever fermentation happens, it produces so many antibiotics in the fermented milk. That is called as antibiotics. To add on one or two more points, used in preparation of ensilage. ENSILAGE, ensilage. Ensilage is a fermented animal fodder. There's a grass called as alfalfa grass. There's a grass called as alfalfa grass that is fermented, and they give it for which one? Cattle. It's a very good animal fodder. One more I'll tell you. Cheese making. It's used in cheese making. Then it is used in sauerkraut preparation. Sauerkraut is a fermented cabbage. Refer the internet, you'll get some more idea. Cabbage is shredded and put in bottles. Just like how we make pickles now. Like that in Western countries, they will use sauerkraut. Okay, we have so many applications of lactic acid. Sauerkraut is a fermented cabbage. Just mention that much. This is only for 1 mark, just to conclude the topic I gave you. All of you understood this importance and all significance?
Yes,
Remember,
sir.
I told you anaerobic acid fermentation, PK pathway, I gave you significance there. It is used in bifidobacterium is very important, develops immunity and all I have given you there. Go through that one. Now I will explain about alcohol fermentation. I have 5 more minutes. Sampriti, take the attendance mark.
Yes, sir.
Oh. Same thing you should write, children. Again, you should write same thing. That's why I took this topic today. What you should write? 1 second. Here, the heading is alcohol fermentation now. What is it called? Alcohol. Alcohol fermentation. Again, same thing. Glucose becomes glucose 6-phosphate, fructose 6-phosphate, fructose 1,6-diphosphate, no? 1,3-diphosphoglyceric acid, 3-phosphoglyceric acid, 2-phosphoglyceric acid, phosphate or pyruvate. Everything is same, children. Until pyruvic acid, same thing. EMP pathway you have to write. How many pyruvic acids you will get? 2. Okay. So 2 pyruvic acids, what will happen? I'm explaining further now. Okay, I'll come to the last part. 2 pyruvic acids are formed. See now, the 2 pyruvic acids that formed will be converting into 2 molecules of acetaldehyde. We'll be converting into acetaldehyde. What is acetaldehyde? It's a compound between acetaldehyde and compound present before alcohol. Understood? So pyruvic acid converts to acetaldehyde. Acetaldehyde converts to alcohol. So here 3 carbon becomes 2 carbon. 3 carbon becomes 2 carbon. Okay, when alcohol is formed, 3 carbon becomes 2 carbon. They lose CO2. Carbon dioxide is removed. Understand? All of you understand that step. Acetaldehyde converts to alcohol by using 2 NADH. Alcohol is formed now. So here reduction. Here that is reduction. Name of the enzyme is alcohol dehydrogenase. To come back here, we can show this also top portion we can show. Glucose becomes pyruvic acid, we can show up there. See here, glucose becomes pyruvic acid by glycolysis. We can show here, same thing we can represent. 2 NAD becomes 2 NADH formation. And here 4 ADP becomes 4 ATP. Just like I told you previously, same we can show. Here it is called decarboxylase. We can show decarboxylase enzyme bringing that function. So what do you get here? Pyruvic acid becomes acetaldehyde. Acetaldehyde converts to alcohol. Okay. So we should follow that alcohol fermentation is brought by. Can you what is this called? Decarboxylase? No. You write pyruvate decarboxylase. Pyruvate decarboxylase removes carbon dioxide. I think I have how much time left? 1 minute left. Children, understand this fast. 2 pyruvic acid becomes 2 molecules of acetaldehyde by losing 2 molecules of CO2. Then 2 molecules of NADH2 becomes 2 NAD. Addition of hydrogen to acetaldehyde is alcohol. Any doubts in this?
No, sir.
I'll send you the pic of this, you follow it up, please. Okay? Same EMP pathway you should write. Up to pyruvic acid you should write same way. If only alcohol is given for 10 marks, it's given for 2 marks, only this much you should write. This much you should write. Clear now? Please practice everything properly. After you come to college, I will ask you these things. Please revise properly and keep. Write all these in your book. At least once I should see all these written in your book. Internal marks matters with the book. I will see all your books. Please write everything without fail. Okay, children? Followed. The class might delay any time, less than a minute. Take care.